All right, North Haven. This is going to be a quick one. Today's topic is going to be multiplying radical expressions. I've been told that I'm no longer allowed to post videos on YouTube, but as of right now, the only way I know how to put videos into a Google Drive is to record them on YouTube and then download them into Google Drive. So for now, we're just going to keep putting up the YouTube videos. Don't get me in trouble. And why are we allowed to make them? I feel like this is helpful. That's a dumb rule. Anyway, let's get right into it. This video is going to be really short. This is a topic that I might even have combined with another topic if we were in school. Multiplying radical expressions. So I got some examples up here of kind of what we're going to be doing. We're going to be multiplying these two radical expressions, maybe sometimes more than two radical expressions. And after we multiply it, we're going to simplify it. And we already did simplifying radical expressions in a different video. All right. So that was the video recorded probably about a week ago if you look at the timestamp. Simplifying radical expressions, that was the first thing we did. Multiplying radical expressions, that's going to be the next thing that we do. So really quick, before we get into examples, I just want to point out that the simplifying radical expressions, that's going to be the worksheet that's 11-3. This one, multiplying radical expressions, this goes along with the worksheet 11.4. I should probably add that to the description, but I feel like I'm going to forget or not know how to do that. So again, I'll say that one more time in case you weren't listening. The simplifying radical expressions is 11-3 worksheet. Multiplying radical expressions, which this video is about, helps with the 11-4 worksheet. And again, these videos are for algebra, so core B students. So one of the examples I had up there was this. We did this in the last video. We found out that we can break up radical expressions like that. So the square root of AB, we can simplify and break it down into the square root of A times the square root of B. That's important. Today, we're just going to be going backwards. We're going to start here and kind of go this way. Another thing I just want to remind you of is that we've kind of already done that when we were doing things like this. We have the square root of 8 times the square root of 8. We know that that's the same thing as the square root of 64. The square root of 64 is obviously 8. And we could rewrite this. It's the square root of 8 times itself. So this is like the square root of 8 squared. And we talked about when we're in school that squaring something and square rooting something are inverse operations. So this ends up just being 8. All right, so that this is kind of the same thing. So that's kind of the big thing to take away here, and that's going to be really helpful when doing these types of problems. So let's get into some of the tougher ones. Actually, before I show you a tougher one, this is actually an easy one, but this is the stuff we're going to be doing. And if you see a problem like this ends up being easy. This is the square root of 7 times the square root of 6, or radical 7 times radical 6. So when we simplify that, we can multiply it and do rad 42. Now, when you're doing this homework and you get an answer, you should be thinking, can I simplify it? Is there a perfect square I can pull out? Those things that we talked about in the last video. Sometimes there's not. The square root of 42, there's nothing you can do. There's no perfect square you can pull out of that. So even though 42 is kind of a big number, and there's some other numbers like that we can break down, this is in simplest radical form. There's nothing more you can do. Okay, I know 2 goes into it, I know 21 goes into it, I know 6 goes into it, I know 7 goes into it, but none of those numbers are perfect squares. So as far as writing this number in simple radicals form goes, that's it. We are done. All right, so let's look at some that are going to involve an extra step, and we're going to have to simplify even after we multiply. So we'll keep it with an easy one. Let's do the square root of 2 times the square root of 14, or rad 2 times rad 14. So there's two ways you can go about doing this problem. The first way is kind of obvious, where we can kind of multiply this together. Square root of 2 times the square root of 14. I got a bunch of different colors. I should use my different colors here. We can break that up into, well, that one stinks. Back to the red. Sorry, I'll use other colors in other videos. So that goes together to get the square root of 28. But now, unlike this problem, this is not in simple radical form. There's a perfect square we can pull out. If you're thinking about it, maybe you realize right now that, okay, the square root of 28, that's the same as the square root of 4 and the square root of 7. And again, if you don't remember from the last video why that's important, I know what the square root of 4 is. The square root of 4 is 2. So I can rewrite my final answer here as 2 rad 7. There's no perfect squares in 7. Obviously, it's a prime number. So you're done, and that's going to be your answer. Now, going back to here, you can get the answer to this problem without doing that. There's another way of doing it. A lot of times in math, I can get to this same final answer a couple different ways. So if you wanted to, you may want to do this as, okay, this is the square root of 2, but the square root of 14, well, I can rewrite that as the square root of 2 to 7. And maybe you're thinking, why would I want to do that? Well, look at that. If you rewrite it like that, I have the square root of 2 times the square root of 2. I can put that together. That's the square root of 2 squared, kind of like how we talked about up here. The square roots and the squaring, multiplying by itself, that's going to cancel out. And you can get 2 rad 7 that way. So same problem, same answer, just two different ways of looking at it. That's going to be helpful when multiplying radical expressions. All right, we're going to just do one more one, and that's going to be it. Because next week, or not next week, but by the time this is assigned to you, I'm going to be holding office hours. So we can go through homework problems. We can go through some problems like this to help you guys out. So I'm only going to do 2 examples in these videos to get you started, and then you can do the homework, and I'm going to pick a time and be on Google Hangouts and help you out with some of those. All right, so now let's look at the ones with variables, because those are the tricky ones. And like I said, this will be the last one I do. We're going to keep this video short and sweet. Rad 3x squared times rad 9x cubed. So variables, we're going to talk about that. It was in the last video, how to simplify radical expressions. Maybe you remember, maybe you don't. All right, so again, 2 ways of approaching these problems. You can multiply everything together and then simplify from there, or you can try to simplify the pieces that are here and try to get a simplified answer that way. So just like we did the problem prior, I'm going to do this the same way. I'm going to do 2 ways, and you can pick which way you like best. So first way, I'm just going to multiply everything together. This is the first method. 3 times 9, that's 27. X to the second times x to the third. Remember your product of powers rule. That's x to the 5th. So now I have 27x to the 5th under my radical. All right, so again, if you remember from the last video, I'm just going to look at that as rad 27 and rad x to the 5th. I'm going to look at each part separately. Is there any perfect squares in 27? 9 is in 27, 9 times 3. So I'm going to write that as rad 9 times rad 3. Is there any perfect squares in x to the 5th? We talked about this in the last video. But remember, the easiest way to get a perfect square from a variable being raised to a power is removing the highest possible even power. What I mean by that is rewrite x as x to the 4th times x to the 1st, or x. Now that I've done that, square root of 9 is 3. Rad 3, I can't really do anything with. It has to stay rad 3. The square root of x to the 4th is x to the 2nd. And the square root of x, there's nothing I can do with that. So now everything is simplified. I just have to rearrange my problem. I want to put the things that are outside the radical out in front. So that's going to be the 3 and the x squared. And the things that are under the radical together under one giant radical. So I'm going to get 3x squared rad 3x is what that is going to turn into. All right, so now I'm going to do this whole problem over again, except now I'm just going to do a different approach. Instead of multiplying everything together, getting this big thing under the radical, and then simplifying it, I'm going to simplify each part here, and then start multiplying and matching up things that are going to kind of cancel out. So square root of 3x squared, I'm going to rewrite that as rad 3 and rad x squared. Square root of 9 times x to the 3rd, I'm going to rewrite that as rad 9. And this x to the 3rd, I'm going to write it as x squared times x. So rad x and rad x squared. So I'm going to break it up like that. The reason I'm doing that is because x squared is a perfect square. So rad 3, there's nothing to do with. Rad 9, square root of 9 is 3. So I have that. And now look here, I got the square root of x twice. So that means I got the square root of x squared twice. You could realize that the square root of x squared is x, and x times x is going to be x squared. Or you can just realize that anything times itself, it's just going to kind of cancel out, and I'm going to be a square root times itself, rather the square roots cancel out, and I'm left with just what's inside the radical. All right, so now we put those together. This has come here. What's still left? I still have the square root of 3. I still have the square root of x. So if you're just being careful with your work and paying attention, you'll see and get to the same answer. So you can do the problem that way as well. All right, I hope that made some sense. I tried to keep this one really short. If you have questions, email me. We're going to hold some office hours on this stuff on Google Meets. Right now I'm going to be meeting with you guys as a grade level in a little bit, so I got to wrap this up. But hopefully that was helpful. Examples to come. Stay well, stay safe, stay inside, and wash your hands.